golden ratio. The golden ratio even applies to human faces, which can be a good or bad thing. The world isn't perfect, and the flaws in the ideal number can have negative effects on those who are afflicted with it. These flaws oftentimes are a sign of health issues and can lead to very serious problems. It's rather common for someone's dimensions to not line up with the standard perfection as we find attractive, which can harm your view of others and their first impression of you as well. Although some deem the golden ratio a myth, I find based upon facts that it is the driving force behind much of our world's workings and necessary to survival. You might be wondering, what on earth is the golden ratio? The golden ratio is a Greek number phi. It is not to be confused with pi, which many people do. It has the same workings as pi, though. It is an irrational number that is found just by chance to be the science behind how the world is working. The golden ratio's proportions can most simply be represented by 3 line segments. Golden ratio values exist when one line, we'll call it A, the longer one, is 1.6180339887498895, and so on, times greater than another line, B. Then line B is 1.6, etc., times longer than C. And again, it's much like pi because it's an irrational number, but it makes a little bit more sense because you can visually show the science behind why phi is the actual number in nature. So go ahead. Next slide. The sunflower is a perfect example of phi in nature. It has the Fibonacci spiral, which Fibonacci is the same measurements. Each sequence is 1.61, etc., times greater than the one before it. And when you map it out and diagram it with the sunflower into the Fibonacci spiral, it matches exactly with it. Go ahead. Another example of phi in nature is actually the face. Angelina Jolie is the closest facial measurements to the perfect phi measurements in nature that we found. You can see that there's focal points along the face, and each focal point corresponds with another line segment on her face that then is measuring 1.61 times greater. Go ahead. These are some common measurements of the face with the relations to phi. The length of the face versus the width of the face, the distance between the lips and where the eyebrows meet versus the length of the nose, the length of the face versus distance between tip of jaw and where the eyebrows meet, the length of the mouth versus the width of the width of the nose versus the distance between nostrils, and the distance between pupils versus the distance between eyebrows. And I found that through Murali on page 15 of his works. Go ahead. Teeth are also a really good example of the golden ratio in nature. Each tooth corresponds to another tooth that makes it 1.16 times greater than the other tooth, and each tooth also has measurements from height versus width, and that is also the measurement of phi. It's vital to healthy teeth and helps avoid major issues in the mouth later on in life. Go ahead. A few more examples in the body. There's thousands of examples, but a couple of the common ones are the DNA molecules with their measurement width versus height. The inner ear, the cochlear tube is like the sunflower. It has a Fibonacci spiral. Heartbeat, as the blood goes into the heart, it is a certain pressure. As it goes out, it's another pressure, and that measurement is supposed to be phi, but sometimes it doesn't happen that way, and that's when you have heart problems. Go ahead. These are a few of the negative effects of not meeting the golden ratio standards. Certain facial structures are proven to be more prone to particular medical issues. Longer faces tend to have respiratory diseases, and shorter faces tend to have abnormal jaws, which affects overbites and placement of teeth, which is why you need to have dental work done at teenage years or later on in life if you don't take care of it then. A large majority of structural diseases are due to the improper proportions of the human body that don't correspond with the golden ratio. So a lot of spinal issues are because the golden ratio isn't lining up perfectly in the back. Go ahead. And here's a study that is relating and proving the golden ratio. What they did is they took a statue and elongated it and also shrunk it and had the normal ratios in it. The statue itself, the original, is perfectly aligned with the golden ratio. The independent variable is the height of the statue compared to the golden ratio, and the dependent variable is the hemispheres that light up when viewing the different statues. Go ahead. This is an example of it. The longer one looks really weird. The middle one is the normal example that lines up with the golden ratio, and the other one is shorter than it should be. So go ahead. Viewers were chosen that had no experience with art appreciation, didn't even find it as a hobby. And what scientists did is they had them look at the 3 different examples, and they were supposed to look at it objectively. But of course, when they were monitoring the hemispheres in their brain as they were looking at it, the hemispheres that lit up were based upon emotions rather than objective viewing of the statues. So it just goes to show that you really can't control the way that you are viewing somebody else. Your mind just automatically is judging them based upon the golden ratio. It's just a natural way that we look at other people. So go ahead. So phi really is all around us, and a normal part, oh, actually, this is just an excerpt taken from the study that shows the science of what hemispheres were lighting up. So go ahead. And in conclusion, phi really is all around us, and it's a normal part of making this world a beautiful, well-functioning place. It benefits health, allows nature to take its course, and affects our body and our first impression of others. I believe, based upon the studies I've seen, that is a driving force behind virtually everything in our universe, even though some find it to be a shaky theory. And without it, who knows how we would judge